In the previous tutorial videos, we learned about the various basics of object-oriented programming, or OOP, and all the basics were actually applied on a single class called points. And in this tutorial video, starting from this, we're going to learn about how to apply the same ideas onto multiple classes as a bigger example. But before we do that, let's review very quickly the items that we went through in the previous tutorial videos. Okay, let's go over the items very quickly. So we talk about object-oriented programming, or OOP, and we talk about the difference between templates versus instances or entities. So these are basically the difference between Java classes versus objects. One is at the compile time, the other one is at the runtime. At the compiler time, what can we do? We can actually define the various artifacts. For example, we can define attributes which will characterize what a particular kind of objects or instances should look like. And also we talk about how you can define three kinds of methods. And the special kind for constructing new instances or objects is called constructor. And also we can modify attribute values without returning anything using a mutated method. We can also inquire about the values of attributes by doing some computations using accessor methods, which will return something. Okay, so these are the three kinds of methods we did in the previous tutorial videos. But now we want to extend what we can do by these methods. Sometimes you may want to change the objects that's not exactly relevant, or that's not exactly inside the current class you're talking about. Okay, that's something we'll get into. And also, when we talk about the runtime, you can actually call the constructor to create objects, as we talk about. And also, really important to know how to use the dot notation. As we said before, whenever you say some object name, dot simply means to go to the store address in the object variable and go to that particular memory location and look up the attribute fields. So that's what we talked about previously. You can get attribute values, or you can try to use the dot notation to call the accessor or mutator. And one thing I didn't really have in the list, which is also crucial. We also talk about how you can use the this keyword in your code. So this simply means the context objects that's being referred to when you make the method call. Okay, if you have any doubts about this concept over here, I will encourage you to maybe look back to the relevant parts in the previous tutorial videos. Okay, let me just give you a very quick preview of the example that we're going to eventually build. Okay, it's going to be a much more complicated example I'm going to show you in the next list of tutorial videos. Okay, basically we're going to have the structure like this. Okay, let me just highlight the critical classes for you, and this is going to be the order we want to go through. Okay, conceptually, we're going to have a student management system over here, SMS. Okay, student management system. That's a case study we want to do for the next few videos. SMS, student management system, and the student management system contains a list of student objects, and the only concept we learned about list is array in this course. So we're going to see how we can use array to store multiple objects in a single class. That's something new we haven't learned before, but we're going to learn in this tutorial video series. And then every student also contains a list of course records as they are registered courses, right? It simply simulates the real world. And every course record also has a single faculty member as the instructor. Okay, that's kind of the relationship we like to build using classes. And at the runtime, we're going to build multiple objects to see how they work with each other by using method calls. Okay, so this is going to be the order we're going to go. First of all, we're going to go conceptually. You can think about go for SMS, and then students, and then course records, and then faculty. Conceptually, that's how you go. But to actually go over the solution with you together, we're going to go for bottom up. We're going to talk about the faculty class first, and then we're going to build on top course record class, and build on top the student class, and build on top eventually the student management system class, SMS. Okay, and for each of the classes we're going to talk about, we're going to have some tester to show you how things work. Okay, so we're gonna have faculty tester, course record tester, student tester, and SMS tester. Each of the tester is going to contain a main method for which we can execute it as a Java application and see the console output. And I will also show you some debugging technique to see how you can debug OOP at the runtime. Okay, that's kind of the roadmap for this long tutorial series. Okay, it's really important for you to grasp every detail I'm going to say in the tutorial video, so you can really understand OOP thoroughly. Okay, let's now try with our first class over here, which is faculty. Okay, so basically, let me just go to Eclipse, and then let's create a class, and I'll explain to you what a class is supposed to do, and then we'll build it, and also build some tester. Let's set up the structure correctly. So what I would like to do is I'm going to have two packages. One is simply called model, which means, so these are the templates I'm going to create. So there will be no main method in any of the 4 classes that we're going to eventually create. Another package will be tests. So these will be the 4 test classes we're going to eventually create. And each one of them can be individually executed as a Java application class. Okay, that's what we'll get into. So I would say, first of all, right click on the source and then say new and then package. So first of all, we're going to create a package called model. Okay. So all the logic, all the OOP will actually mainly go into model, okay, to develop the classes. And then let's right click on the source folder and say new and package. Let's create another package here called tests. Okay, so all the console application classes for the testing purpose will go into tests folder. Okay, so now let's create our first class. Okay, inside right click on the model package over here and say new and class. Okay, the first class will be faculty. Okay, remember the naming convention for class, it should be capitalized for every word in the compound word. And then no main method inside the model package. Okay, and then we'll say finish. Okay, at the same time, we're going to create a tester right away. So there's something called test-driven development, which means as soon as you are developing your code for the logic, you should really create a tester correspondingly just to test along the way. Okay, so now we're going to right-click on tests and then say new and then class as well. So over here, we're going to say faculty tester. What about just tester after the class name? Okay, so we're going to say faculty tester here, and then with a main method, and then I'll say finish. Okay, you can see now we got 2 classes. One under the model, the other one under the tests. The one under the test actually got a main method, which means we're going to execute this particular class as Java application to see how things can be tested out. Okay, let's go back to faculty first. Okay, for the faculty here, I just want to review very quickly what we said about in the previous tutorial videos and introduce just one new concept called aliasing, but I'll get there. Okay, so now let's write some comments over here. Okay, you can see each faculty, basically a faculty member, each faculty member has their name, campus address, and let's say phone extension, campus phone extension, campus phone extension. Okay, this is something you can look up in the university faculty profile. So just standard information. Okay, so let's say these are the 3 things: the name, the address, and the extension of the phone that we can characterize each faculty member. Okay, and then we're going to define some constructor for that. So let's say for simplicity, just for the review purpose, let's define only one version of the constructor. Of course, in theory, you can define as many versions of the constructor as you like, as long as their lists of parameters and their types can be distinguished from each other. Okay, that's what we said previously for the point example. So now what I will do is I'm going to define a constructor. So I would say faculty over here. Remember, the name of the constructor must be the same as the class name. And then I'm going to choose, before I define the constructor, let me define an attribute first. Okay, again, I'm going to have the first section over here, attributes. Okay, so each faculty member will be characterized by the following variables that are of the scope to every method in the same class. So I'm going to say string name. Okay, each name should be a string. And also, let's say address is also a string. String address. Okay, so these 2 variables should be quite easy to see their types. What about extension? Extension could be, for example, let me just give you, for example, here, extension basically just a number. It could be 70310. Okay, in that case, the extension can be a string. You can say it's a string literal which contains 70310. On the other hand, it can also be stored as an integer, which will be 70,310. Okay, that's completely up to your judgment as a developer. Let's say, let's just have a different type just for fun. Let's say I would say integer and then extension. Okay. Okay, so these are the three attributes for each faculty objects. So each faculty is characterized by exactly these three attributes. And now let's define just one single version of the constructor. I'm going to say faculty here. And then now, what names can I choose for the parameters, for the inputs, for the methods? So now you have two options over here. Either you can choose the names that do not clash with any of the names for the attributes, and then you don't have to use the keyword this. Otherwise, if I am lazy, I might just choose the attribute, the parameter name over here, just the same as the attribute name here. As we learned in the previous video, you must use the this keyword to disambiguate. Let's follow the latter because that's more common practice. Okay, if you have doubts about this, please refer to the previous video for details. Okay, so here I'm gonna say string name. You can see the name over here has the same name as the attribute name over here. And also I have string address and also integer extension. Okay, so these are the these are the three input parameters I have. So now what should I assign? Basically, I want to initialize the name attributes to be the input name. I want to initialize the address attributes to be the value for address, right, and etc. So what I should do is I should say this dot name is assigned to the name. Again, if you go, if you try in Eclipse, if you move simply left click on this name over here, you can see that one refers to the input parameter by highlights, right? If you actually put on the name over here, because we got this at front, it's going to refer to the attribute at line number 10. Okay, notice that it's really important to use the this when you have to. Even though when you don't have to use the this keyword, it can still help you when you trace the execution of the code. Okay, so now the second line will be this dot address is assigned to the input variable address, and also this dot extension is assigned to the extension. Okay, so these are the three assignments I need to write. Okay, so now let's see what's here. Okay, so this dot address. Okay, let's see. There's a yellow highlight over here. The assignment to the variable address has no effect, so this dot address is assigned to. Oh, I see. The reason is I just spelled it wrong. Okay, the address over here should be the same as this is just misspelled. Okay, address. Okay. Okay, so now we are okay. There's no yellow underline for any warning, so we are fine. Okay, so now we have our constructor, and then let's just see what we can do in order to go further. I would like to show you some tests right away in order to actually get further. Let me define some very simple accessor for you, very simple ones. Let's say we want to return the attribute values, right? Let's say we want to say string get name over here. Okay, I can simply say return this dot name. Okay, I can also have let's say string get address. Okay, and then I can say return this dot address. Okay, you can see this is kind of tedious to write out if I want to define the accessor and mutators for the attributes. I want to show you something very quickly which can be automatically generated using Eclipse. I'll show you. Okay, let me just get these out very quickly, and then what I will do is I'm going to select all the three attributes. I want to generate some useful accessor and mutator for me to manipulate these attribute values. I can simply right click and then go to source, and then you can go to generate getters and setters. Getters over here, which means to get something out from the objects. So this is exactly the accessor that we're talking about. We have a look at the setters, which means we want to set the attribute values to be something. So that's exactly the mutator that we have been talking about. Okay, if you click on that, generate getters and setters, and now we got these three attributes over here. You can see for the address attribute, we can generate get address and also set address. So this is the accessor method we can generate, and this is the mutator method we can generate. And similarly for all the other two attributes, I want to generate all of them, so I can simply select all of them over here, and now there's an access modifier. I can just say public. As I said before, in this course, you don't have to worry putting the public for your code. All you have to know is public simply means all the other classes in the same project can actually use this class. That's what it means. Okay, so now let's say we want to put them at the end. Okay, so now let's say after the faculty constructor over here, right? We want to say all things should be generated after the faculty, and then they should be also you can sort it by, let's say it can either be a getter setter pair, or it can be first scatters and then setters. Let me just choose the second one. You can play with that a little bit with the tool. I can say generates. You can see these are what's generated for you for that particular class. So these are very simple getters and setters or accessor and mutators that Eclipse can generate for you. Feel free to use it if you want to use it, okay, if you find it necessary. And you can see that over here, when we say, let me just draw your attention very quickly. For these three accessors over here, you can see we didn't really use this name. However, implicitly, if you move, if you left click on the name, it's really referring to the name at line number 10. So that's really the attributes. Because in this particular case, there's no parameter over here, so there's no chance of confusion. So that's why you don't have to use this. On the other hand, if you look at this particular method over here, mutator, you can see there is a parameter over here which is of type name, which is of name. You can see this name over here clashes with the name of the attribute over here in line number 10. So this is why we had to use this keyword, just like how we taught you in the previous video. So Eclipse does generate something like this. So there should be no problem for you to understand what's being generated. Okay. Again, you can generate either getters or accessors, or you can generate setters or mutators, or you can generate both. That's completely under your control what you want to generate. But I'm just trying to show you how to use the tool. Okay, so now we have finished the faculty class, which is very simple. It should be no surprise to you. The faculty class looks just like the point class that we talked about in the previous videos. What I want to do is to help you trace the code a little bit after I develop the tester. And I want to introduce one new concept to you. Okay, that's really important to understand the rest of the tutorial series for this week. So let's now move to the faculty tester to write some tests to create the objects and try to manipulate the objects. I want you to draw your attention to this. You can see that the faculty tester, again, it belongs to a different package called tests. On the other hand, the faculty refers to belongs to the model package. Whenever you want to say this class over here, faculty tester, is going to make use of some methods from the faculty class, you have to make sure, number one, the faculty class over here, for example, the constructor, must be public. Okay, that's something you have to add in. However, later on in the lab test, you will be given all the classes inside the same package, the default package, so you don't have to worry about the public. But now for the lab exercises or for the tutorials, we want to be a little bit more sophisticated to show you what you can do beyond the lab tests. So now, let me show you exactly what I meant. So if you go to faculty tester over here, you can see at the moment, the constructor for the faculty class is simply just no public, which means it's only visible inside the particular package called model. It's only visible inside or there, not outside. If I go to faculty tester over here, if I try to create a new object, I have to declare the type first of all. I can say faculty, okay? If I only say that, it's going to, if you move your mouse over, it's going to say faculty cannot be resolved, which means it's not recognized yet. What you have to do now is to make sure you import this particular class from the package. So you can say, so once you type faculty over here verbatim, you're going to say control space. And then Eclipse is going to give you a drop-down menu over here to say what faculty are you talking about. Basically, you're talking about the faculty in the model package over here, right? Exactly there. As soon as you choose that one, it's going to, you can say line number 3 was added for you. Gonna say import model.faculty. And later on, we're gonna import different classes as we go on. Okay, you're gonna say faculty over here. Let's say F1 is assigned to new faculty over here. That's a constructor name. And then we're going to pass in, let's say faculty over here. So what should we give? We should give a string name, string address, and integer phone extension. Let's do that quickly. Okay, it's going to be name, let's say Jackie, myself, and also the address, let's say Lassonde building, let's say 2043, and also the extension. Okay, let's say, for example, like that. Okay, now, even though we follow the constructor parameter types, you can see it should be first a string, and also a string address, and also an integer extension. We did exactly that. However, it wouldn't compile. Let's see why. If you move your mouse over the error, it says constructor faculty string integer is not visible. Okay, why? If you go back to faculty over here, you can see there's no public in front of the faculty. Remember, let me emphasize again. The faculty class is declared within the model cluster, and the faculty tester is declared within the tests package. So these two packages are different. So that means if you want to use inside faculty tester some methods from faculty, you have to make sure the methods you're using are public. Okay, so what we can do is go back to the faculty class over here and say public in front. Okay, that's all you gotta say. Again, in the lab tests, you don't have to worry about putting the public yourself because all the classes will be put within the same default package. Okay, let's go back to faculty tester over here. Everything compiled. So now we are creating one object of type faculty called F1. Okay, and then I'm gonna create another one. Let's say F2. Okay, over here, what about I say Jonathan over here? Let's say Lassonde 2045. Okay, I'll make up some extension. Let's say 209, for example. Okay, you can see now we're creating two objects over here. As we said before, whenever you use a separate new keyword, you're creating a new separate object in the memory, which means these two objects, object number 1 and object number 2, they have different addresses in the memory. And these two addresses will be stored in F1 and F2, respectively. So now, if I try to compare the addresses for F1 and F2, let's see quickly how that will look like. I can say system.out.println. Okay, I can say F1 and F2 store the same address, whether that's true or not. Okay, you can say plus. Okay, I can say over here F1 equals F2. Okay, what do I expect to see? I should expect to see false. Right, let's verify that very quickly. Okay, if I go to the Package Explorer, right click on Faculty Tester and say Run as Java Application, I will get over here F1, F2 store the same address. It is not the case. Okay, we'll use the debugger in just one moment. Oh, actually, let's use it now. If I put a breakpoint over here, and then I would say debug this particular class, and then I'll be switched to the debugger perspective. Over here, you can see we are pausing a line number 10 after we have created the two objects in line number 8 and line number 9. Let's see F1 and F2. Okay, if you simply click on F1 here, it gives you some pseudo address, as we said. So you can see all you got to pay attention to is this value over here, 644-2B086. Okay, it's one address. On the other hand, F2 is of the other address, which is distinct, 60F82F98. All you have to know is these two addresses are not the same. And if I go to expressions over here, let me just delete the previous one. Okay, I can simply say delete all of them. Okay, so now if I simply say F1 over here equals F2, I can see that it's simply false, right? They're simply different addresses. Okay, so now we have created two faculty objects. That's what we have done. I'm going to draw some diagram on the iPad for you in just a moment. Okay, so this is something we know pretty well. Let me go back to Java perspective. Let me show you one more thing before I show you something new. Okay, so there are different addresses, and now I can try to print out some something from them. Okay, what I can do is I can go back to faculty here. Let me define one more accessor for us. We want to know exactly, we want to have some string description. Let's have a standard just for the sake of simplicity. Let's say for the rest of this tutorial series, we're going to have a accessor method called getDescription. Whenever you have a context object, let's say faculty F, let's say a faculty F, f.getDescription is going to give you a string representation of the faculty objects. Let's do that quickly. Okay, over here, I'm going to define a new method. Okay, let me move that to the middle over here. So I can say string will be the return type for the accessor. And then I would say, let's give a, I also make it public so that it can be used outside the model package. So string, I would say get description. Okay, so it will take no parameter because this accessor here is only going to depend on the attribute values which are already visible to the accessor, so we don't need any extra inputs. Okay, so over here, let's try to define what should be returned. I can say declare something that's the same as the return type, which is string. I can say string result is assigned to empty string to begin with, and then return the result in the beginning. So this is the minimum I have to write in order to get it to compile. Let's get it to work. I can say the result is simply reassigned to, let's say, faculty, and then I can give the name, this.name, okay, resides on, okay, how about this, has campus address, how about that? And then also we got this dot address over here, and then plus. Over here, I can also say and extension phone extension plus this dot extension. You can definitely split this into several lines. It's completely up to you. But for me, just for easiness, I just typed them in the same line. Of course, let me fix this typo here. Should be result over here. Okay, let's give it a try. Okay, basically, simply say that this get description over here is simply just going to tell us what the attribute values are, the critical attribute values for this particular faculty. We're going to say the name and also the campus address and also the phone extension. That's what we'll see. Of course, if you like, you can reorganize the formats for the description. I'm just giving you one possibility. So what I will do is I'm going to go to faculty tester over here, and then I'm going to say system.out.println over here, and then I'm going to say f1.get description. Okay, and then I'm going to do another one. Let's say f2.get description. So we got f1 and f2. They should be different objects and with different descriptions. Okay, okay, let's do one more time. Okay, so now let me execute the code, and then you will see that faculty Jackie has campus address Lausanne 2043 and phone extension this, and also you can see that. Let's look at these two. These two lines were generated by f1.getDescription versus f2.getDescription. If you look at these two lines are similar and also different in different ways, right? They are similar in the sense that they all got faculty over here has campus address and also has campus address and phone extension and phone extension. This is where they are similar. They're different in the sense that since the method over here, getDescription, let me show you here. The method getDescription is going to call this.name and also this.address and also this.extension. Remember what's this? This is simply the context objects for the method call. In this case, this is simply f1 versus f2. So it depends on what the context object is, you might have different result. Okay, in the first case, this will be replaced by f1. In the second case, f2 will be replaced by this will be replaced by f2. Okay, I'll draw some diagram to you in just a moment. Okay, and then after this, we're going to have just have this description over here. Let me do one more. Okay, I want to do two more and then introduce you to the new concept. Now I want to do another one. What if I have something here? Okay, I'm gonna say f3. So now I have a question for you. If I have f3, how is f3 different from f1? Are they the same objects? Number one, question number one. Okay, questions. Let me put it here. are F1 and F3 the same objects? That's question number 1. And also, let me say Q1 over here. Q1 and Q2. Do F1 and F3 have the same contents, attribute values? Okay, so these are the 2 questions for you for F1 and F3. Okay, so now let's try that. To answer question 1, I can do the following. Are they the same objects or not? If they are the same objects, that means they should really store the same address, right? So let's try that. If I say system.out.println, and then I can say over here, F1 and F3 are the same objects over here. Is that true or false? Okay, and then I can simply say it's going to be F1 equals F3. Okay, take a guess before you see me running the running that as a Java application. Okay, if I try that, I'm gonna see F1 and F3 are the same object, which is false. This is false because F1 was created using a new keyword. F3 was created using another new keyword. So that means they're not the same objects, even though their attribute values might be initialized to be Jackie, and Jackie here for the faculty name, Lasang 2043 and Lasang 2043 also the same, and also 70310 also the same here. Okay, you can see there are 2 separate concepts over here. When you talk about 2 objects being the same objects, you mean you're referring to the same memory location. On the other hand, if you talk about they have the same contents, that means you're talking about their attribute value. So these are 2 different things. Okay, so now let me just do another one. Okay, now if I say system.out.println, okay, so now I can say F1 and F3 have the same contents. Basically, their attribute value, and we know pretty well we can check the printout of the contents using the get description method. Why don't we do that quickly? Okay, I can say over here. So now I can just put a Boolean expression here to be printed out. So let me show you something I will also try to analyze for you. It's going to be a little bit more complicated method call, which you also want to get used to. I can say F1 over here dot get description. We know that this particular method call is going to give me a string value, right? The value, for example, like over here, F1. However, I want to compare this string value here with another string. How do we compare string value? We have to use the dot equals method, right? I'm going to say dot equals. You can see F1 dot get description alone over here is going to give me a string. And for any string expression, I can say dot equals. And then I'm going to give another string. What can I do? I can say f3.get description. Okay, this one looks more complicated than what you did before. So what I could have done, I could have stored f1.get description into a string variable. I can store f3.get description into another string variable and then contain their compare the contents using equals. That's another way to do it. But now I do want to show you the more sophisticated way to really write method call and also to compare string value. That's something I want you to pick up, okay, right away. Okay, so that's again, let me repeat very quickly. F1.get description is a method call that's going to return a string value. It returns a string value, so we can say that value dot equals another thing. And now what's inside as the input for the equals method is just another string value. And we get that string value by taking the return value of f3.get description. We want to say if they are the same contents, right? Let's do that. And then if I say enter, launch, it's going to say they are not the same objects over here, but they have the same contents, the attribute value, which means f1.name Jackie will be the same as f3.name Jackie. f1.address will be this, which is the same as f3.address over here, and etc. Okay. Okay, so these 2 questions are very important for you to understand and also how to figure out their concept, their answers. Okay, let me do one more thing. I will trace everything together with you at the end using iPad. Okay, let me do one more thing here. So now, if I try to do the following, if I say faculty F4. That means I'm trying to declare a new faculty object over here, right? Let me spell it correctly. Okay, faculty F4. So now, rather than storing a new address of some new objects into F4, what I will do is I'll say F4 is assigned to F1. This is also something new you haven't learned before previously. Okay, this is something called aliasing. Aliasing in the sense that I have F1 over here that stores the address of some previously created objects over here. So that particular object has the name F1. But now I'm trying to say that F4 is also going to store whatever that is stored in F1. Okay? So I'm going to trace everything together with you, don't worry. And then what's going to happen after this? Okay, so now we have the same two questions. Okay, let me just, can I just copy this block of code over here? And then I'm going to ask you the following. Okay, let me just control A, Control I, just to fix the indentation. Okay, so now let me just fix this quickly so you have all the record over here. Are F1 and F4 the same objects? Okay, so F1, F4 are the same objects, F1, F4. Okay, that's number one. Okay. Do F1 and F4 have the same contents attribute values? And F1 and F4 have the same contents. Now I will say F1.getDescription now equals F4.getDescription. Okay? Do you think previously, right? Previously what we get is for F1 and F3, they are different objects, but they contain the same, they store the same attribute values. But what about F1 and F4? Okay? So now we're going to see. Intuitively, okay, there's a spelling error here. A-L-I-A-S-I-N-G, aliasing. Okay, intuitively, we are basically storing the address that is stored in F1. We store the same address into F4, which means F4 right now is also referring to the same object as F1. So now they really refer to the same objects. Okay, so now if I try to execute the code over here, it's going to be now F1 and F4 are the same objects. True. You can compare this together with the previously false between F1 and F3. Okay, it's really important for you to see. I'm going to visualize things to you after this. And also F1 and F4 have the same contents, also true, right? So now let's trace the code very quickly. Okay, very quickly. So what I would like to do is I'm going to move between the iPad and also the code. I want to do line by line. So now let me assume that you are familiar with over here the constructor for the faculty class, right? We're going to initialize the name, address, and extension, and also these three attributes. For that part, I'm going to trace how to trace the constructor creation for you, since that was already covered in the previous tutorial video. Okay, what I will focus on is what's really going on over here for these lines of code. Okay, so what I will do is I'm going to use debugger and also iPad at the same time. Okay, let me do it all together. Okay, now first of all, let me simply put a breakpoint over here in line number 8, right before we try to create F1, right before that. Okay, and then I'm gonna say debug over here. Okay, so now we're gonna have this. Okay, let me just go to the variables panel over here. Nothing has been created just yet, so F1 is not there yet. So what I would do, first of all, if I simply say step over here, if you say step over, we're going to have F1 over here, right? If you expand the options for F1, we got address, we got extension, we got name. Specifically, F1 has the address 644.2b0a6. Okay, that's actually quite important. I will explain to you. Okay, so now let me just draw what we have got so far. So and now, what we have done is we have created an object over here of type faculty. Okay, let me just try to use a bit thicker over here. So we have an object over here of type faculty. Okay. Okay, again, I expect that you actually know how to draw rectangles like this to represent objects. That's something we cover in the lecture notes and also in the tutorial videos. And for each faculty, we have, remember the name, the address, and extension. Okay, we got, for every faculty, we actually got 3 attributes. We got the name, we got the address, we got the extension. Okay, so now for this particular one, we got Jackie Lasson 2043. Okay, let me just write it down. Jackie and then Lasson 2043, and also we have the extension 70310. 70310. So that's the first object. And now, what's the address? Okay, if you go back to the debugger over here, and we say the address is simply 644.2b0a6. 644.2b A0A6. 0A6. Okay, it's just one address over here, right? And then we know that basically F1 over here is going to store that particular address. So conceptually, we can think about F1 is just pointing to this particular object over here. And again, this address over here is simply stored inside F1. 644.260A6. Okay, 2B actually. 2B 0A6, the same address. Okay, again, the object variable F1 stores the address only for the objects. Okay, we do the same for the next line. If I say step over again, okay, it's going to create F2. Okay, F2 is going to be created in a similar way, but now F2 has a different address. I'm going to copy that in just a moment. Okay, let me draw the diagram first. Okay, so we got another object being created. Let me draw that quickly. So this particular faculty object goes here. The structure will be the same because the type is the same. So now for every faculty objects, we have the name, we have address, we have the extension. So the name over here is Jonathan. Okay, that's the name. What about the address? Address will be Lasson 2045. Okay, Lasson 2045. And also for the extension, it's going to be 70209. 70209 over here. Okay, so now what's the address over here? For the address, it's simply going to be 60F82. 60F82 and F98. Okay, that's the address over here. The absolute value for the address is not important, but what's really important is the blue address and the green address, they are different addresses. Okay, that's what's important. And then we got F2 over here, which is also going to store this this particular address over here to F98. Okay, it is now pointing to this object over here. Okay, again, object variable does not store the entire object, it stores its address only. You can look up the address in the Eclipse, okay, when you run the debugger. Okay, it's really important for you to understand this concept for the address. So now over here, when you see this particular line, when I say F1 equals in line number 10, F1 equals F2, we're basically asking whether this address over here equals this address over here. Apparently, it should be false, right? They are the different address. That is why, if I say step over, you're going to see false over here. Okay, you can disregard this line here. Okay, nothing wrong with the logic over here. And then we're going to call get description. Okay, and now if you recall previously how we trace the accessor method, basically F1, F2, we're going to execute the same block of code back in faculty over here. Let me just show you one thing that's really interesting. Okay, so now I want you to remember we said before, let's say get descriptions exactly here, right? We're going to execute this block of code for 2 times, right? One time, we're going to say the context object this is replaced by F1. And the second time, the context object will be replaced by F2, right? And we want to see exactly how this can be done, can be seen for the debugger. We have seen that in the previous tutorial video in the iPad, but now I want to show you very quickly. So now, remember we also copied down the address for F1, F2, so things will just make sense in just one moment. It's really important for you to pick this up and try to reproduce yourself. So now, rather than saying step over, I'm going to say something we haven't done before, step into. Step into over here simply means we're going to go into this particular method call. Okay, so now if you go to this particular method call, let's predict what's going to happen. If you want to execute this method call over here, we're going to go into the class for defining this class method over here, which is faculty. So we're going to see exactly this faculty over here. But now the only difference is we're going to replace every occurrence of this by f1. Okay, f1 which stores the address of this value over here. Right? Okay, remember? Okay, so now if I say step into, let's see what's going to happen. If I say step into right now, you can see we are indeed in the context of the faculty class, and we are trying to execute this line over here line by line. Okay, now I want you to go to the variables panel over here. You can see there is the this. What has this been replaced by? If you look at this over here, that's exactly this faculty object with this address 6442B0A6. 6442B0A6 over here, right? Exactly this address over here that we replace the this by. Okay, so now that's something very important for you. So what I said previously to say replace every occurrence of this by the context object f1. So that's exactly what's been done by Eclipse as well. That's something that's a bit tricky. I want you to pick up for this point over here. And then once you get this, what will be the address? Address, extension, and name will just correspond to what I drew over here. Okay, that will be very easy to see how the string will be returned accordingly. Okay, so now let's say I want to walk out of this method over here. I can simply say step return. Okay, so now I'm finishing executing line number 11. If I say step over again, so now it's right before I try to execute the same block of code, get description, but now with a different context object, which is f2. Now let's just try to do one more exercise. If I say step into over here, what's going to happen? Basically, we're going to switch the context into this particular method again, but now every occurrence of this is going to be replaced by f2, right? f2 is basically storing this address over here 60f8 2f98. We can verify that's the case once we say step into. Okay, if now I say step into over here, okay, so now we are in the same block of code inside faculty. It's called get description. So now if I go to variables panel here in the debugger, what's this? If I click on that, 60f8 2f98. 60f8 to f98. That's exactly this address over here, right? Let me use the right color. It's exactly this address over here. You can see we are trying to execute the same block of code twice, and every time it's the same block of code that's being executed. However, the context object this. Okay, the first time this is simply this object address, which is referring to this particular object, and the second time this is replaced by this particular address, which means the context object we're talking about is this object over here, right? So now that's something I really want you to get used to. Whenever you're trying to make a method call, what really matters is the context objects, right? Because when you talk about different context objects, you would have different effects of the method call. Okay, that's about these two lines. Okay, so now I would like to go on with the debugging. Okay, so now we are basically over here. Okay, so now we're going to say step return to walk out. Okay, so now we're going to say step over. So now we're basically just into this particular line. We're going to create a new object called F3. This part is easy because for F3, we're simply just going to create a new faculty object. Let's do that very quickly, okay? So what I will do is I'm going to create another faculty object over here. Let me just do it on iPad, okay? So I'm just going to create a new object over here, F3. Okay, a new faculty object over here. Basically, every time you see the new keyword, that means you want to draw a new box. Okay, the structure of the box depends on which type of object you're creating. In this case, faculty name, address, and extension. And intentionally, we say F3 should be Jackie 2043 and the extension, right? So it's gonna be the same over here. So it's gonna be Jackie over here, and then Lasan 2043. And also 70310. You can see it's different objects. Let's verify that. If you go there, and then what we're going to see is if you say step over. If I say step over here, what's the address for F3? Let's look it up. If you look at variables over here, F3 is of different address, right? Different from the previous two objects. 35F98. 35F98. And then we also got 3A6. 3A6. So that means after we have created this particular object over here, we're going to assign its address, which we just copied down, into F3. Let's do that quickly. Okay, that means F3 over here is also going to store this particular address, 35F98 3A6. So conceptually, it's pointing to this particular object. Okay, so you can see that's exactly how you should know how to trace the program. Okay, so now it's storing that. That is why when we try to do this, when we say F1 and F3 are the same objects, that's not true because F1 is referring to this particular address here. F3 is referring to this particular address here, so they are not the same. Okay, even though their attribute values are the same. Okay, you got to notice which one we are comparing. Okay, so now if you simply do that, I can also do in the expressions. I can say over here, F1 equals F3. Okay, over here it's going to say false. Okay, if I say step over, okay, it's going to be false. Okay, finally, over here, F1 and F3 have the same contents, right? If you try to do this, okay, let me just, over here, let me write this down here. We say F1.get description, okay, dot equals, and then we say F3 dot get description. Let me try to help you understand this line very quickly. Okay, actually over here I forgot to include the empty parentheses. Let me do that very quickly. Okay, so that's precise. So now this is how you can understand this line here. So this part over here, get description, this particular method call is going to return a string value. And also F3.getDescription over here is also going to give you a string value. When you want to compare two strings, you'll simply say dot equals. Okay, that's it. That's how you understand this line. You might see something similar to the tester I'll give to you later. Okay. Okay. So after this, I'm going to trace further. So if you look at line number 18 over here in the tester, you can see we are basically, as I explained, we're trying to call f1.getDescription, where we have the context object being f1. And also we are trying to call the same method again for the second time, and now the context object becomes f3. Okay, so now you can verify very quickly by the expressions panel over here. I can say f1.getDescription. Okay, you can see that it's going to say this string over here, right? If you look at what's f3.getDescription, f3.getDescription over here is going to give you basically the same contents. You can see this string is exactly the same as this string over here. However, there are different objects. As you can see, f1 and f3, they're simply not the same. They don't store the same addresses. Okay, again, you can see f1 and f3, they are different objects, different addresses. However, their attribute values are just the same. Okay, you really want to distinguish between the addresses for the object being the same versus the values for different objects attributes being the same. Okay, you should want to distinguish between these two phenomena. Okay, let's go on to line number 20, which is very interesting. Okay, if you go there over here, F4 is assigned to F1. Okay, so now this is really important concept for you. It's called aliasing. In real life, aliasing simply means a single person might have multiple names. Okay, you're really talking about the same person objects, but that person may have different names that they go by. Okay, so now it happens the same OOP. Okay, so now let's think about a little bit more like at a lower level, and then I'll show you how you can draw conceptually in a very easy way. Think about this. We know that, as we emphasize so many times, when you talk about object variables, they really store addresses. So F1 over here stores the address that we talk about over here. It stores just this address over here, okay, which is the address for the blue object here. What about F4? We're saying that initially F4 is simply just going to be assigned the value that is stored in F1. What does that mean? That literally just means the following. Okay, let me just try this. Let me put F4 with a different color. You can think about F4 is basically just a variable over here. And then we are saying that F4 is simply just going to store the address that is currently being stored in F1. What is that? F1 is storing this particular address, which I'll put it down. I'm going to copy that into here, 644.26086. Okay, if F1 and F4 they actually store the same address, how do we conceptualize that? Easy. That means F1 and F4 are pointing to the same objects. So this is how I would draw. If they store the same address, that means F1 and F4 they point to the same address. That is why after this, if I say F1 equals F4, you can think about it from two different perspectives. Number one, you can think about F1 is storing this address over here, F4 is storing this address over here, so they are the same. So equals should really make sense. It should be true. On the other hand, you can try to go a little bit higher level if you know how to draw. F1 is pointing to this particular object over here, whereas F4 is pointing to the same object over here, which referring to the same objects. So that's also how you can judge. So equals simply means, do they point to the same objects? In this case, yes, they point to the same objects. Okay? Hopefully you can see from the two perspectives, their equivalents. But maybe knowing how to draw will make your life easier, how to trace. So now if I want you to draw attention to this. You can see at the moment we are right before trying to execute this initialization here. As soon as I say step over, we're going to see that F4 is going to be created under variables, and F4 is going to contain just the same address as F1. If I say step over here, you can see F4 is created, and now it's address 644.2b086. 644.2b086, right? Exactly what I just illustrated. So now I can just go to the expressions over here. If I say now, over here, F1 equals F4, so now they are said to be aliased because now true is actually true because F1, F4 they store the same addresses, they store the same address, so they point to the same objects. Okay, so that's what we call aliasing. Okay, F1 and F4 they are said to be the aliases for the same objects. Okay, I'll write it down for you after I exit from the debugger. Finally, if we ask about this here, F1, F4 they have the same contents. So now it's really the same comparison we are trying to do as in previous comparison over here. So now, given that F1 and F4 they refer to the same objects, so this question here, whether F1 and F4 should produce the same description, should be a no-brainer. They should be, because we are basically asking, even though I'll trace it together with you. Basically, when you talk about in this particular case, F1 dot get description over here versus F4 dot get description. Okay, let me prove it to you very easily. We know that when we try to execute this particular method, and for this particular method for the two times, the first time, every occurrence of this is going to be replaced by F1. F1 is exactly this address over here, 644.2b086. When we execute this particular method call, every occurrence of this is going to be replaced by F4. F4 is also storing this address here, 644.2b086. And conceptually, you're really saying, what is the description for this one here? What is the description for the object that's being referred to by F1? What is the description for that? That's one thing. And for the second one over here, what is the description for the object that's being pointed to by F4? And it's talking about the same objects. The same object, of course, it will have the same description, the same, right? So now I would like to just go back there and then try to see this. Okay, so now I'm going to just show you very quickly. Okay. And now F1, F4 they are different. So now what I will do is I will simply just step over. Okay. So now as I explained before, F1 and F4, even though they look like different names, but they really store the same address. That is why when you say F1 that get description, it's going to give you the description for this particular orange objects. On the other hand, when you say F4 that get description, it is also going to give you the same description for the same objects. Okay. So now I would like to do one more thing before I end this video. It's very important for you to understand aliasing. It's really important phenomenon to understand for OOP. Okay, so now aliasing, okay, that means F1 and F4 are two different names for storing the same address for the same objects. Okay, so now I want to do one thing very quickly for you. Okay, now I have the following question. Remember we got mutated method previously, right? Let's say we got a mutated method, let's say set name. Let's say I want to change the name. My question is as follows. If I say let's say this string s1 is assigned to let me just change something first. If I say f1 dot set name over here, let's say rather than Jackie is going to be, let's say, Hyun over here. Okay, so now after this I have a following question for you. Okay, what if I say system.out dot println, let's say f1 dot get description, and I'm also going to say f4 dot get description. Okay, let me make it even more explicit for you. Okay, this is going to be f1. Okay, and then this is going to be f4. Okay, this is my question for you. Based on what you learned previously, this part should not be too difficult, because it seems like I'm just calling a mutated call on f1 and set the name to be here. So what I should really see is, from this particular method call, I should say the faculty here has the campus address Lausanne 2043 and then whatever extension it is. Now the question is for F4. Previously for F4, this is what happened. For F4, I'll show it to you. For F4, it seems to be referring to the same objects over here, but is it going to remain Jackie or Hyun? Okay, that's my question for you. Okay, so now let's see this. Okay, let's verify this on Eclipse and then I'll show you on the iPad. Okay, now if I simply execute this block of code, you can see that over here, for F1, it's simply going to be here. That makes sense because we did change that by using F1 being the context object and change it to here. But why it also changes F4? That's my question. Why does it also change F4? You can see over here we say F4, faculty here, not Jackie anymore. Has campus address Lausanne 2043 and phone extension this. So what's going on over here? So this is a very important phenomenon, the consequence for having aliasing. Okay, so now let me write it down in words for you, and then I will illustrate to you on the iPad, and then we are done. Okay, we say because F1 and F4 point to the same objects using any of the names, either F1 or F4, to as the context objects for a mutator method call, will have the effects visible to all the names. Okay, it's a little bit formal over here, but basically what I'm trying to say is, even though you only say f1.setName, but it's as if you also say f4.setName simultaneously, simply because f1 and f4, they refer to the same objects. But now how do you trace this on the iPad? It's actually incredibly easy. Okay, let me write it down here. Okay, so now this is what we have from the previous discussion there. So now we know that f1 and f4, they point to the same objects. But now what I have was this. I say f1.setName over here, and then I say here. Let's think about what's going to happen over here. Okay, we learned about how to trace a mutated method call in the previous video. I'm not going to do that here, but what I want to show you is, you can see that what we have is, going back to faculty here, set name is going to say this.name is assigned to name, right? So what we used to have is this.name is assigned to name. Okay, that's according to definition. But now the name will be replaced by Hyun over here. On the other hand, what about this? This will be the context object, which is f1, which is this address over here. Okay, I'll just say f1 over here. f1.name is going to be Hyun, F1 following this, the dot over here simply means to look up the objects, right? F1.name will be replaced by here, over here. And then notice that, as I said in the second part of the sentence over there, I said any mutated method call will have the effect visible to all the names, which means not only that this here new change is visible to F1, but also it's also visible to F4 because F1 and F4 they point to the same objects because they're aliased together. So now you can see that after this line here, if I say F4 over here dot name, okay, F4.name is going to follow this link over here, and then .name will just refer to this particular name attribute, which is also here. So that is why it's also visible. Okay, so now it's really important for this video. We both review what you learned previously about the OOP basics, but also we introduce a very important concept called aliasing. So you really want to make sure you review this particular test over here to make sure you're comfortable with. Number one, whenever you're trying to compare addresses between two objects, you know when should be true, when should be false. And number two, whenever you say, I want to initialize an object variable, but now rather than using a new keyword, I'm simply just going to copy the address that is stored in some existing objects into there. So that means we're having an alias situation. So it's really an address copy. Address copy is like a low level of thinking. You can feel free to think about we are just let the arrow of F4 point to the same objects that's being pointed to by F1. That's a better way of thinking it. It's easier for you to keep track of. And then finally, we learn about whenever you're trying to use, let's say, an object in general. In general, let me draw down one more picture for you. In general, if you look at the iPad over here, let's say in general, let's say you have one particular object in the memory. Let's say you simply alias to so many different variables because we simply do so many copying of the address of the same address. Now, if I try to use this particular, let's say name number one, object number two, let me say this. This can be object one, object two, object 3, and object 4. Now, if I simply use object 1 to make a mutated method call to modify somewhere in this object here, that change will be visible to all the other names because it's as if you try to make this mutated method call using O2 or O3 or O4 because they refer to the same objects. That's a really important concept for you to pick up. Okay, and then review this and then know why. So for now, F1.get description will just give you the same description as F4. They both change the name to be here. Okay, so now review this concept. Make sure you're comfortable before you go on to the next video.